Transformations of sine and cosine graphs include our translations that shift our graph left, right, up, and down. They also include vertical and horizontal stretches and shrinks, which impact the period of the function, and also the amplitude of the function. So you're probably wondering what some of these words mean or how they relate. So let's talk about that. Here we have the sine curve, which you should be familiar with now. So we have this sine curve, and this is one cycle, one complete period. So a period is the horizontal length of one complete pattern. And then what happens is the graph repeats itself to the left, it repeats itself to the right, but your first, or your, doesn't have to be your first, but one complete cycle, one complete pattern is the period. And in this case, the period is 2 pi. So that means the horizontal length, which is the definition of the period. So the horizontal length, which is the period, is equal to 2 pi. And the period equaling 2 pi is going to be common with your sine, your parent function for your sine curve and your cosine curve. So let's take a look at the cosine curve. So the cosine curve, remember, it starts at the max, it ends at the max. There's one full cycle for your cosine curve, and the period as well, because it's the same curve, it's just shifted. We've already talked about that. This is a period of 2 pi as well. So we're going to be talking about transformations that impact the period so that they are horizontally shrunk to be less than 2 pi and horizontally stretched to be greater than 2 pi. We're also going to talk about the amplitude, and the amplitude is the length from the midline. So let's identify that midline. So in purple, I'm going to identify the midline. The amplitude is the length, the distance from the midline to the max. So the amplitude is equal to the distance from the midline to the max, or the midline to the min. Because midline is going to be halfway between the max and the min, so it is half the distance from the maximum to the minimum. Lots of different ways to define that, but hopefully you can visually see here that the amplitude in this case is equal to 1. It's a distance of 1 from 0 to the max. From 0 to the max is 1. From 0 to the minimum of -1 is also a distance of 1. And that's going to be true on your cosine curve as well. So we've got our amplitude, we've got the period, we've got the midline. The midline is halfway between your maximum and minimum. And here's basic characteristics of the parent functions for both the sine and the cosine curve. The domain is negative infinity. Let's change this so I can write a little bit better. Is negative infinity to positive infinity. So this graph goes to the left forever and it goes to the right forever. The range, however, for this parent function includes -1. That's the lowest point it's going to get to. Here's -1 right here. Let's write -1 right there. So it goes as low as -1 to as high as +1. So the range is -1 to +1. This is on the parent function. And then the period is equal to 2 pi. It has a horizontal length of 2 pi. X-intercepts. The x-intercepts, those are interesting. Those occur at every pi value. So this is how we're going to write that. The x values are at any pi value. So any whole numbered pi. So n is any integer. And integer are whole numbers and their opposites. The y-intercepts, there's only going to be one of them because it's a function, is at 0, 0. This is an odd function, very important for you to note. This is an odd function. I did do sign in yellow, so I want to highlight that in yellow. And it has symmetry about the origin. Symmetry about the origin. That's true with any odd function. Any odd function is going to have symmetry about the origin. And this is why symmetry is so important, because then you can relate it to whether or not you have an odd or even function. Now the domain for the cosine curve, which is the same as the sine curve, it's just translated, is also negative infinity to positive infinity. It will go to the left forever. It will go to the right forever. The range is the same. It goes as low as -1 to as high as +1. And the period is 2 pi. But its x-intercepts, see, its x-intercepts are going to be at all the pi over 2's. So at all the pi over 2's. So how we write that is pi over 2 plus n pi. If I take pi over 2 plus 1 pi, that would give me 3 pi over 2. If I take pi over 2 plus 2 pi, that would give me 5 pi over 2. And then, of course, I could subtract as well. I could do pi over 2 plus -4 pi over 2. And that would give me -3 pi over 2. So that's how that works. All the pi over 2's is where your x-intercepts are going to be. For the sine function, all of your whole numbered pi values are your x-intercepts. And then, of course, your y-intercept, let's do this in maybe green. Here's your y-intercept on the cosine curve. Your y-intercept is going to be 0, 1. Now, the cosine curve is an even function. It has symmetry about the y-axis. So what's to the left is to the right of the y-axis. You can fold it right on top of itself and it lands. If you fold on that y-axis, the left side will land exactly on the right side. So these are important features of your sine and your cosine curve for us to use as we transform our parent functions.